How are you guys? Welcome back to my channel. We're still under properties of fluid. It's fluid mechanics and 5. We'll discuss about again viscosity, but now we're dealing with formulas and calculation. Formulas. Deal with them. Deal with formulas and calculation. It's viscosity. We're still under viscosity. Now, FFD, we did define viscosity. We are no longer now. Let's say now we're dealing with viscosity. Let's say under circumstances when we're given, let's say, piston and cylinder. Piston and cylinder. Note, let's say now we're given piston and cylinder. Here it's our cylinder. Here it's our cylinder. Then as we have we have the cylinder there. In this cylinder, let's say that we have a piston, which is a cylinder and a piston. Now here is the piston here. Piston, then here it is a connecting rod. There's a connecting rod. Right, this is a cylinder. This is our piston. Right, so let's say this piston is moving in this direction. It's moving upwards, moving in this direction. Now this is the piston bore. We have the length of the piston itself. Piston bore, you can see letter L. This size of the piston bore. It's a piston. Then we have, you can see, this is the diameter of the cylinder. This diameter here, you can call it capital letter D. This is capital letter D. Right, we have the capital letter D, and then also we have small letter d, the diameter of the bore. This is the bore of the piston itself. Let me say here, small letter d. Right, we have a cylinder. This is the diameter of the cylinder, piston. Then this is the length of this thing, and then there is little space here. You see this space. this space between here, we call it clearance. This space is called clearance. We have a clearance. There's a clearance there, CR, right? Then is moving that side, which is the velocity, is represented by x with a dot here, or you can also, if you like, you can represent it by letter V as velocity, but yes, you can see velocity is represented by x with dot, it represents velocity, right? Cool. Now we know that if we're given this thing, we can say we want the area of these things. The area is supposed to be a circumference of the piston. The circumference of the piston we multiply by what? By the length. Circumference of the piston multiplied by its length, right? Then we know this circumference is given by what? Remember, circumference is given by pi d and l. Area is multiplied. Do not make mistake under this topic viscosity and use this or pi over 4 multiplied by d squared. Will be wrong. This one we use this is no longer this. The area now is pi multiplied by diameter multiplied by L. Diameter of the piston, length of the piston, this one multiplied by the diameter, multiplied by the length that it is moved. Okay, so that it's area, and then we know area is measured in meter cubed, meter squared, so not cubed, is that is volume, meter squared. It's measured in meter squared. Okay, it's fine. It's measured in meter squared. We also know that a force over area, we know that this is a force, when you're given force over area, is directly proportional. This is and represent proportionality to the, this is a rate of shear strain. This is the rate of shear strain. Force over area is directly proportional. This represents proportionality symbol. Is directly proportional to the rate of shear strain. Whereas we know that also force over area we know is equal to, under these topics also we know is equal to coefficient, right, multiplies by rate of shear strain. But the rate of shear strain is calculated by velocity divided by clearance, right? Rate of shear strain, right? This is the rate of shear strain. This theta with a dot on top, this is the rate of shear strain, is given by, it's calculated by velocity over clearance. So mathematically, if we substitute now, we know that now it's supposed that I take this mathematically a force over area, right? Substitute this here, substitute the rate of shear strain here, will have nu, then you substitute this, will be multiplied by x theta velocity divided by clearance. Take that and substitute that. Now we have this. Now let's multiply let's multiply the A that side. Mathematical, when you apply, yeah, let's multiply this there on the top. Now force alone will be, take that, you multiply that side, this will be area. Remember remember mu is what? Is dynamic viscosity, or it's a viscosity, same thing. Then velocity divided by clearance. This is how we came about to calculate the force. Now the imported formula is this one. Force is equal to area multiplied by the viscosity multiplied by velocity over clearance. What you're supposed to know is this one. This is unnecessary on top. What is important for you is this one. You're supposed to know that one. This is what is important for you. You're supposed to know that stuff there. That stuff there. That formula. Okay. Okay. Now, clearance is the space. Let's say we are given something. If you are given a piston, you're given a cylinder. This is the piston, right? Or I have, this is a piston. This is clearance. This space here is clearance. You see this space, the smallest space, this one, it is a clearance. So how can you get this space? Obvious, we know the size. We have D and then we have small letter d. How can you calculate the clearance? Clearance will be given by big D, the one of the cylinder, divide by, not divide, sorry man. Look, you subtract that D of the, that D of the piston. You subtract small letter d, right? You take this, you subtract the small letter d, then you divide by what? By 2. Then we give you what? Clearance. This is the imported formula. Big D is for cylinder, this is for piston. Divide by 2, you get what? The clearance is the formula to calculate a clearance, right? Now, since you know that formula, so you must know what does it represent there. You must know everything that, let's see, A is area, U is viscosity, CR, this is clearance. So on this formula, this is area, A, it's area, nu, this nu is what is viscosity, right? Is viscosity, or is known, alternative name is dynamic, right? Dynamic viscosity also. Then X with a dot on top, this one is what? It's a velocity, as you know, is measured in meters per second, right? Clearance is measured, this is a unit, is meter, right? This coefficient of viscosity is the same, is the coefficient of viscosity, right? Coefficient of viscosity, we know, known as dynamic. Then we have force. This is the force. You know, force is measured in what? In Newton. Then, yeah, you are done with this, the formula. Now you're supposed to apply, to put this information, you can put it to work. Now, remember again, to calculate the power. Remember, power is force multiplied by velocity originally, right? Or power, it's work over time. Now, let's use this one. Power is force multiplied by what? Velocity. The velocity we represent by what? By x bar. What about the force? What is force here? Force is the whole of this thing. This is the force. But force, we know that the force is area multiplied by dynamic coefficient of viscosity over velocity over what? Clearance multiplied by what? Multiplied by the velocity. This is what it is. Power measured in what? In watts. Is always right. So what you're supposed to know. So what it's important that you're supposed to know with this. And when you are using area, when you are using an area, load, I supposed to, let me just write small capital, did not the big one. This is a, let me write D. It's a D of what? Of the piston. Must be a diameter of the piston, or a shaft if you're given a shaft only, or a shaft, right? This D, when you are calculating an area, must be small d here. Must be this, must not be this one of the cylinder, but must be D of the what? Of the piston or a shaft, right? When you calculate what? The area. Make sure to not forget that. We only use this D of the cylinder only here on this formula. Only there's no, you can, if you, there's no way you could apply, you will only use this big D, the diameter of the cylinder, only for clearance. If you want clearance only, you'll use it when you say D minus D of the piston or of the shaft divided by 2 only. There's no way. You understand? If, like say example, if you are given a shaft, we have something like this. We have a shaft. We have a shaft. Here, this is clearance. This space, it is a clearance. Also, when you calculate the area here, your area is pi d, small d of the shaft multiplied by L. This will be d of what? Of the shaft. Right. Clearance, we know will be big D. There will be a D of the whole things. This D here will be big D. Then there's a D of the shaft. You understand? It will be D where it is kept minus the D of the shaft divided by 2. Right? Do not make mistake. Do not make mistake. Do not make mistake on this area. It's a pi D L, D of the shaft. Length of the shaft. This one. If you are given this scenario. Right. I hope you understand this. I hope you understand this. Hope you understand this. Right. Now, let's see. Okay. Let us do the, I was just putting up an intro. This is an intro. We will do activities, or we will do question in the next comment section. Stay tuned. Do not forget to subscribe, and do not forget to like this video so that you'll be notified anytime when I post a new video. Stay tuned. Stay tuned. I'll post when I'm dealing with problems. So it's important that you have this foundation first. All of this information, you'll be able to answer all these questions based on viscosity. Then after this viscosity, we'll deal with kinematic viscosity, right? Then, but now we're still under this viscosity, or we're still under dynamic. Can say here or dynamic. This is or dynamic. This is dynamic viscosity. See, one and the same thing. Yeah, we're still under viscosity or dynamic. This information, it's what you need to apply. Then this of the shaft fall under kinematic viscosity. Let me erase this one. We'll delete when we are looking dynamic viscosity, when the shaft are rotating. Remember, the piston is not rotating, it's going upwards, or it's going up and down. It's going straight, its linear motion is up, or it's going down, but the shaft is rotating. Remember, when you have a shaft is rotating. Yeah, shaft is rotating. Maybe there will be some motion there, you understand? Then rotational motion. This one, we're still under this dynamic. Right, so stay tuned, guys. Don't forget to subscribe. Okay, share this video to your fellow classmates. Stay tuned to the next comment section. Thank you for watching this video.